Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 22, 2026, just 2 days ago. It demonstrates that representation autoencoders can replace standard variational autoencoders for large-scale text-to-image generation, achieving up to a 4.6 times speedup on benchmarks while avoiding the catastrophic overfitting seen in state-of-the-art models like Flux. The paper is titled, Scaling Text-to-Image Diffusion Transformers with Representation Autoencoders. And as we'll see later, the implications for unified multimodal modeling are quite significant. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates these dramatic convergence gains during pre-training. The plots track performance over 60,000 iterations, comparing the proposed representation autoencoder in blue against the standard Flux variational autoencoder in orange. On the left, looking at the general eval metric, the new model matches the baseline's final quality 4 times faster. The right chart confirms this on DPG bench, showing an even larger 4.6 times speedup, which suggests that learning in a semantic space is significantly more efficient. So, Figure 2 demonstrates why data scaling is crucial for generalizing beyond simple objects. The rows display reconstructions of a boxing match, a tank, and dictionary text. In the second column, the decoder trained only on ImageNet fails completely on the bottom text row, which highlights the limits of that dataset. But in the third column, after scaling to 73 million examples, the text becomes sharp and readable. This brings the performance in line with the Flux VAE shown on the far right. So, while Figure 2 showed the visual impact, Table 2 quantifies the reconstruction error, where lower numbers indicate better performance. The top rows list the VAE baselines, showing that Flux sets a very high bar with the lowest scores across all categories. However, looking at the bottom rows, the RAE models, specifically the highlighted SIG LIP2, have successfully surpassed the widely used SDXL VAE. For instance, on the challenging text domain in the far right column, SIG LIP2 achieves a score of about 1.6, which is a solid improvement over SDXL's 2.1. Alright, while the previous table compared the final models, Table 1 here breaks down how data composition drives those results. The rows show the progression from ImageNet-only training to a diverse mix of data. Notice in the first row that using only ImageNet results in high error on the text benchmark. But, in the highlighted bottom row, explicitly adding text rendering data forces that error down to 1.6, proving that targeted supervision is essential for fine details like glyphs. Well, Figure 5 shifts the focus to model scaling, plotting performance as the diffusion transformer grows from 0.5 billion to nearly 10 billion parameters. In the top row, utilizing a fixed language model, the blue line for the representation autoencoder consistently dominates the orange VAE baseline. The bottom row shows this trend holds even when upgrading the language backbone. Specifically, the dark blue line reveals that with a 7 billion parameter language model, the RAE maintains its distinct advantage in generation quality across all scales. Okay, moving from scaling to stability, Figure 6 reveals a critical difference during fine-tuning. The plots track generation quality over 256 epochs, with GenEval on the left and DPG bench on the right. Notice the orange line for the Flux VAE. It improves initially, but then suffers a catastrophic drop after 64 epochs, which signals severe overfitting. In contrast, the blue line for the representation autoencoder holds steady and consistently outperforms the baseline, suggesting that its semantic latent space inherently resists overfitting. To wrap up, 2 main points stand out. Representation autoencoders offer a simpler, more stable foundation for large-scale generation, effectively solving the overfitting issues inherent in traditional VAEs. By unifying visual understanding and generation in a single high-dimensional space, this framework opens exciting new doors for integrated multimodal reasoning. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.